We have computed the shadow price of one of the empty cells that we are calling W1C2, and I was saying you can use the stepping stone, you use the surrounding, in this case they are all filled cells, as you compute that particular shadow price. Let's have the computation of the shadow price of W, this cell here. It is empty, as you can see. Let's compute its shadow price, which is cell W1C3. So again, we'll ask ourselves, as we use the stepping stone, which are the nearest stones that we can actually utilize. So for this one, we have got quite a number of issues to consider. We'll start from where the cell is, and as we go round, we can't use this stone here because it is empty, so we'll step on it. We'll move to the next stone, in this case the cell W1C2 will use its unit price. So if we have stepped on this stone, then it means the corresponding column stones cannot actually be used, if at all the resultant elements, or rather the cells themselves, are actually empty. So we'll not use the whole of this column for the computation of the shadow price, for cell W1C3. So I'll start from this cell. It has a unit cost of 120 with a plus. Remember, we alternate the signs. Then we'll take away, so I'll skip on this stone and I'll step all the way to this stone whose unit cost is 100 in fact 100. Then I'll go and utilize this cell here. It has a unit cost of 140. And then I'll step on this. I'll not utilize this stone. I'll move all the way to this particular stone, whose value again is 140, the unit cost. I'm using the unit cost, not the amount of units assigned. We are using the unit cost. So I've gone round. Make sure you complete the movement. You move in a rectangular manner, or in a circular manner, but you must have to make that particular complete rotation. So we have 120 minus 100 plus 140 minus 140. That will give us a positive 20. It will give us positive 20. How else could I have found this particular, maybe a shadow price? If let's say we had something here, we had assigned some units in this particular cell, it would have been possible for us to just involve those surrounding the neighboring cells to compute the shadow price. But why I skipped on that particular cell, it's because it was actually empty. Assuming again, this particular cell had something, but this was empty, but this could be it was filled. Again, I would not have used that particular stone. I would have stepped on it and I moved to the next stone, assuming here we had some allocation, and then I'll still be making a full rotation as I compute that particular shadow price. Let's see now how we can get the shadow price of this other empty cell here, which is equivalent to cell what? This is cell W3C1. Cell W3C1. Let me write it here. C1. No, W3C1. We are starting with the law followed by the column. W3C1, we want to compute its shadow price. What are we going to use as a surrounding? Now, this is a very good example actually. This cell itself is where we want to begin, and we can move either clockwise or anti-clockwise. For me, I'll move anti-clockwise, but you can still move clockwise. So I'll start from this particular cell itself, which is actually empty. That should always be our starting point, with a positive unit cost, 160. Now, how are my surroundings? This cell has something, this one is having something, but this one is empty. So I must step on this particular, I must keep it, yeah? This particular empty cell are not utilized, meaning the adjacent stone should also not be utilized. So I'm going to have this particular computation. I'll skip on this particular cell and I'll move all the way, because these ones too are actually filled in, until I'll make a complete rotation. So I have 160. I'll minus this one here. We are moving, and I've moved how? I've moved clockwise, but I can still do it the other way around. That is, and clockwise. Let me stick to my procedure from the beginning. So I'll skip on that. I'll move around until I come back to the cell where I began. So we have 160 positive. We'll minus this 140. My direction is this way. Yeah, 140. Then I'll also add this 140 here. Remember, we are using the unit cost. And then I'm going to subtract finally 140 here, which gives us a positive 20, which is actually 160 minus 140, 140, and this will cancel. So we'll have a positive 20 as the shadow price for W3C1. And you can also do it the other way around. Actually, you'll still get the same result. If you rotate and clockwise, you'll still have the same result. Finally, we compute the shadow price for cell W3C2. It is also empty, as you can see. Let's do it here. Cell W3C2. If you're to look at where the W3C2 is seated, the surrounding, the neighboring, the immediate neighboring cells are already filled in. So that one you have no struggle into getting the computation of the shadow price. You just go around and you can do it clockwise or even anti-clockwise. For me, I'll move anti-clockwise, okay? Just as we did it to the other cells. So I'll start from here. This is my starting point always, from where the cell is. Then I'll move round until I'll make a complete rotation. So we have 120. We are using the unit cost. And remember, where you begin, the value is supposed to be positive. Then we are rotating with a negative sign. We take the cell that has an amount. Here we take 140 as our unit cost. Then another cell that has some amount. Here we have the 28 units. We take the unit cost, which is actually 140. And we are using a positive sign. And then lastly, we take away 80 as the unit cost. This is 80. So this will give us a figure of what? Let's do the calculation. This 140 and this will cancel each other. 120, 80, positive 40. Wow, this is good. All the shadow prices are positive. What does that one mean? For the first cell, that was W1C2, we got a positive 40. This one we found positive 20. Here we have found positive 20 again. And lastly, this is giving us positive 40. What does that one mean? there can never be a better occasion than what we did. And therefore, our solution is optimal. That is the best minimum cost we can ever have, which was shillings 66,400, in that all the shadow prices for the empty cells have proved to be positive. If for anything you have already computed your shadow prices carefully, and that there exists some shadow prices which are negative, you should move the units into a cell, as many units as possible, into a cell that has the highest negative shadow price. Negative and the highest negative shadow price. You move the units from one cell to that cell which could be having a negative shadow price as guided by the highest negative value. And therefore, you still evaluate, you do more allocations until you come up with a figure you can call the transportation cost, and you still check for optimality, that is using the degeneracy as your concept, and you evaluate the shadow prices again, check whether there could be some negativity. If so, the solution is not optimal. If all of them turns to be positive, like in our case here, then the solution is now optimal, and there's no more kind of an allocation that you can consider to do. That should actually be your best allocation. And that is what makes the transportation problem as part of the LP iterative, in that you keep on repeating the previous steps up to a point where you ask, is the solution optimal? Yes, and therefore no further steps will be required in that case. For us here, this result is already optimal, in that from our calculations, we have all the shadow prices being positive, and so it means there's no other better occasion, and thus the figure of shilling 66,400 would actually be the best kind of a solution we'll give to this particular problem. Before we move to the next problem,